Rab explains it all. Math, chem, physics never fall. Subscribe and learn. Ace every test, so Rab explains it best.
Hi everyone, I hope you are doing well. Welcome to this video and welcome to my channel. In this video we are going to learn how to draw a distance time graph. But before watching this video, I strongly suggest you to pause this video and watch another video which is about interpreting a speed from a distance time graph first, because there are several key points in that video that can be useful for drawing distance time graph. Okay, let's start with solving examples. Here we have an example. A person walks 300 meters in 100 seconds at a constant speed to a friend's house. So this is going to be the first part of the distance time graph. He is going to stop to talk for 200 seconds. 200 seconds. This is going to be the second part of our graph. And then walks 300 meters to school in 300 seconds, gradually increasing the speed. And this is the third part. The question, once distance time graph, okay, we are going to draw distance time graph. I'm going to call this axis D and I'm going to call it T. As you can see, distances here are based on meter. So inside the parentheses, I'm going to consider the unit of distance meter, and time is based on seconds, so I'm going to consider t based on second. I'm going to start from origin, right? So this is going to be the first point of the first part. What do I have in the first part? A person is supposed to pass 300 meters, right? So I'm going to separate 300 meter in the distance axis, and this 300 meters is going to take 100 seconds, so I'm going to separate 100 seconds in the time axis. So I'm going to find the point, I'm going to continue them until they intersect. So this would be the ending point of the first part. But how am I supposed to connect these 2 points? Am I supposed to connect them like these, connect it like this, or connect it like this? Because I am able to draw different lines, right? So, do we have another information about the speed? Yes, as you can see, he passes the first part with a constant speed. When it says constant speed, it means the line must be straight. So, a straight line must connect these 2 points. Let's go for the second part. Then he stops to talk for 200 seconds. When he stops, it means the distance is not going to increase, right? The distance will remain the same, which is 300. And he stops for another 200 seconds. So I must add 200 to this one, and I'm going to have 300. Distance is not going to change. It means it's going to remain 300. And this is the ending point of the second part. What is the initial point of the second part? This is the ending point of the first part. Now I must connect these 2 points, and you definitely know from the video that I told you, when someone stops or speed is 0, we have a horizontal line. And it is clear here, right? Then he walks another 300 meters to school. So we must add this 300 to another 300, which is going to be 600. And this part is going to take 300 seconds. So I must add 300 to this axis. I'm going to reach to 600. I'm going to continue them until they intersect, right? Now I must connect these 2 points. But how am I supposed to connect them? It says in this part we have increase of a speed. When we have increase in the speed, in the value of a speed, we are going to have a curve, and the concave of curve must be up. It's really simple. So in the first part I have a straight line. In the second part, because that person stops, I'm going to have horizontal straight line. And in the third part, because the speed is changing and the value of the speed is increasing, I'm going to have a curve, and the concave of this curve is up. Here in the second part, we have a delivery robot, and it travels in the first part 400 meters, and it passes this part in 100 seconds, and we have decreasing its speed. So this is the information for the first part. It stops, it's important, for 50 seconds. This information is for the second part, and then the robot travels another 600 meters to a second delivery point in 150 seconds and increasing its speed. The question wants distance time graph. I'm going to draw the first quadrant of coordinate plane. This is going to be the distance, and this is going to be the time. Because I have the values of distances based on meter, the value of distance will be meter, and t will be based on second. We are going to start from the origin, and for the first part, we can realize that this robot is going to pass 400 meters. I'm going to specify 400 meters on the distance axis, and it's going to take 100 seconds. I'm going to find the point. This is the point. How am I supposed to connect these 2 points? Look, in the first part, speed is decreasing, right? So it's going to be the curve because the speed is changing, and because it is decreasing, the concave of the curve must be down. So it's going to be like this. And it stops for 50 seconds. So I must add 50 seconds here. It's going to be 150, and because this robot is not moving, so distance is not going to increase, right? It's going to remain 400, and you definitely know when the object is not moving and the speed is 0, we are going to have a straight horizontal line, and we just connect them with a horizontal line. And for the last part, the robot is going to travel 600 meters. So I'm going to add this one by 600. It's going to be 1000. And this part is going to take another 150 seconds. So I'm going to reach to the 300. If I find the ending point, it would be here. Okay, how am I supposed to connect these 2 points? In this part, we have increasing the speed. The speed is increasing. So first of all, it must be a curve because the speed is changing. And second of all, the concave must be up because the speed is increasing. And it would be the distance time graph. Really easy. Next example, a bus travels from the city center to a town. In the first part, what do we have? It's going to drive for 1 hour, and it covers 30 kilometer constant speed. This is the first part. I strongly suggest you to highlight useful information that you can find in the question. Okay, it's going to help you a lot. And anyway, it's not going to hurt you. I do not know why some of the students resist against the suggestions of the teacher. It then makes after that it stops. Okay, for 30 minutes. This is the second part. And after the stop, again, it moves and drive another 30 kilometer in 19 minutes. And the speed is increasing for the last part. This is the third part. Okay, let's draw it. Distance time graph coordinate plane. And this is going to be distance. This is going to be the time in the first quadrant because most of the distances are based on kilometer. This part I'm going to have kilometer. And when I have kilometer, it's better to write it based on hour, t based on hour. So I'm going to show it with h. We are going to start from origin. In the first part, as you can see, it's going to take 1 hour. I'm going to show it here, and it covers 30 kilometer here, right? Let's find this point. I must connect these 2 points, but how am I supposed to do that? Because I have constant speed, I'm going to connect these 2 points with a straight line, not a curve. After that, it's going to stop for 30 minutes, right? Here I have 30 minutes, but as you can see, the unit of time on this axis would be hour. So what am I supposed to do? I must convert these 30 minutes to hour. It's really simple, دیگه. 30 over 60 is going to be 1 over 2 or half. So I'm going to add 0.5 and I'm going to have 1.5. And because the bus had stopped in the station, the distance is not going to change. It's going to remain 30. And when something stops, it means the speed is 0. We are going to have a straight horizontal line. We easily connect them with a horizontal line. And then it's going to pass another 30 kilometers, so plus 30. For in the third part, I'm going to have 60 here. And in 90 minutes mean 1.5 hours. So I'm going to add this plus 1.5. I'm going to have 3 here. Let's find the last point, and I'm supposed to connect these 2 points. But how am I supposed to connect these? The speed is increasing, so I'm going to have a curve because the speed is changing, and because it is increasing, the concave must be up. It's exactly like this. Here you can find more examples, and I strongly suggest you to solve them at home. If you have any question or if you wanted to share your answer, please feel free and write them in the comment box. I will try to answer them as soon as it was possible for me. Thank you for watching this video.